Learning about mesh analysis, how to solve the circuits using mesh analysis. So the first step in solving the mesh analysis is, first of all, you need to consider how many loops you have in the circuit. So we have one loop, loop two, and we have third loop. So always remember that you have to take the direction of current flow in each loop, either in clockwise or in anti-clockwise. So that means, let's suppose for first loop I took clockwise, I have to take second loop also clockwise, third loop also clockwise. I cannot do one loop clockwise and second anti-clockwise. So you need to be careful that if you are taking clockwise direction, for each loop you have to do clockwise. If you are considering anti-clockwise direction, then for each loop you have to take anti-clockwise. So I am considering clockwise direction. So let's suppose current flowing in this loop is I1, here it is I2, and this is I3. So we have labeled the loops and we have labeled the current flowing through each loop. When I say current flowing through loop 1 here, so that means I1 current is flowing here, here, going this way, and then going back here. So this is the loop that I1 current is covering. So we will write KVL equation, that is Kirchhoff's voltage law equation, for first loop. If I start from this point, I need to start from here and then complete this loop and come back to the same point. So I'm starting from here. I see negative here, so I will put minus 12. Then I go here, here. So what is the current flowing in 6 ohm resistor? It is I1. So I1 current is flowing here, 6 ohm resistor. So plus 6 I1. Then I go downward here. So it is current flowing in 6 ohm resistor is I1. Current flowing in 4 ohm resistor is I1 going downward. But 4 ohm resistor is shared by two loops, loop 1 and loop 2. So that means there is some current flowing in 4 ohm resistor due to loop 2. So what is the current in loop 2? So in loop 2, we will say that here, this is I2 current flowing in loop 2, I2 going here, I2 going this way, and I2 going this way for loop 2, right? So now when we are writing the equation for first loop, current flowing through 4 ohm resistor is I1, that is going in this direction, I1 minus I2. So in 4 ohm resistor, there are two currents flowing. One is due to loop 1 and second is due to loop 2. So we are writing equation for loop 1. So I'm considering the direction here this way. So I1 goes in this direction, I2 is going in opposite direction. So we will say here 4 I1 minus I2. Then I reaches here and then I go back to the same point here. So we completed the loop and we have written first equation. I will simplify this equation, minus 12 plus 6I1 plus 4I1 minus 4I2 equal to 0. Minus 12 plus 10I1 minus 4I2 equal to 0. So we have written the first equation. Now I have to write the equation for loop 2. So let's suppose for loop 2, you start from this point. I'm going upward. So current flowing in 4 ohm resistor is I2 and I1. So since I'm writing the equation for loop 2, I'm following the direction of loop 2 I2 current. So I2 minus I1, because I1 is in opposite direction, times resistance. So this 4 ohm is resistance, and this is the current. So that represents the voltage drop. Then we have covered this portion. Then we reach here. Then we go in this side. So this is plus 6. Then I go this way. Then I go this direction. When I reach at 2 ohm resistor, 2 ohm resistor is shared by loop 2 and loop 3. In loop 2, I2 current is flowing in this direction, but I3 current is flowing in opposite direction. So I3 is going this way, then this way, then this way I3, and then going this way. So when I'm writing the equation for 2 ohm resistor in loop 2, so I was following, I'm changing just the color here so that it's more clear. So we have done up plus 6, then I go here, then I go here. So I'm following the direction of I2. So I2 minus I3, I2 minus I3. That is the current 2 ohm resistor times resistance that give you voltage. Now we have reached at this point, and then there is nothing in this branch, so we completed this loop equal to 0. So we have written the equation for second loop. So now you solve it. 4I2 minus 4I1 plus 6 plus 2I2 minus 2I3 is equal to 0. So 4I2 plus 2I2 gives me 6I2 minus 4I1 minus 2I3 plus 6 equal to 0. So we have written this equation here. So we combine these two, then 4I1 and then minus 2I3 plus 6 equal to 0. Now we will write the equation for the third loop. So the third loop here, let's suppose we start from this point. I go in this direction. So I3 is the current flowing in 2 ohm resistor, and I2 is the current flowing in 2 ohm resistor, because this 2 ohm is shared by loop 2 and loop 3. So I'm writing the equation for third loop. So I'm going in the direction of I3. So I will start from I3 minus I2 because it's in opposite direction times resistance. Then I reach here, then I follow this. So in this 2 ohm resistor, the current is I3 only. So it will be 2 times I3. Then we follow this direction. So this is negative here first. So I will say minus 2. Then we go this way. Then we go here. We reach through this loop. So we close this loop and we have written the third equation. So now simplify. 2 times I3 minus 2 times I2 plus 2 times I3 minus 2 is equal to 0. That gives me 4 times I3 minus 2 I2 minus 2 equal to 0. Now, if you see here, we have equation number 1, we have equation number 2, and we have equation number 3. There are 3 variables, I1, I2, and I3, and now we have 3 equations. Now, the next step is to solve these 3 equations. You can use any method to solve these 3 equations. So you can use either substitution method or you can use matrices, whatever method is convenient to you. So what I will be doing is I will be using substitution method. So I will find from equation 3, I will solve for I3. So I'm rearranging equation 3 here. So 4I3 minus 2I2 equal to 2. So from here, 4I3 is equal to 2 plus 2I2. I3 is equal to 2 plus 2I2 divided by 4. So I have found the value of I3 in terms of I2. Now, in equation 2, there is I3. So I will substitute the value of I3 in equation 2 here. So the equation 2 is, I will just highlight this equation 2 here. So I will substitute the value of I3 in equation 2. So let me write the equation 2 on the second page. So just give me a second here. On second page. So my I3 value that I found was 2 plus 2 I2 divided by 4. And my equation was 4 I3 minus 2 I2 minus 2 equal to 0. So I will substitute the value of so this is the equation from where I derived this thing, and I will be substituting it in this I3 value in equation 2 from our previous page here. So that is this equation. So I will rewrite this equation here. So that was 6i2 minus 4i1 minus 2i3 plus 6 equal to 0. So substitute the value of i3 in this equation here. So 6i2 minus 4i1 minus 2 plus 2i2 divided by 4 plus 6 equal to 0. So you solve this. So this will cancel out 2 here. So 6i2 minus 4i1 minus 2 plus i2 denominator plus 6 equal to 0. Now to make it common denominator, I am dividing the whole thing with 2 and then multiplying with 2 here. This gives me 12i2 minus 8i1 minus 2 minus 2i2 plus 12 divided by 2 equal to 0. So this 2 goes on this side. This will be 0 now. So 12i2 minus 2i2 gives me 10i2 minus 8i1 plus 10 is equal to 0. So now I found equation in terms of, I can find in terms of i2. So 10i2 plus 10 is equal to 8i1. So I can say it from here that I1 is equal to 10i2 plus 10 divided by 8. Now I will go back to my previous page. So now I found the value of I1 in terms of I2. So I can substitute in my equation number 1. So I will rewrite this equation number 1 on the next page and substitute the value in here. Equation number 1 is minus 12 plus 10i1 minus 4i2 is equal to 0. I got this equation from this page here, this one, right? Now substitute the value of I1 in here. So it will be minus 12 plus 10, 10i2 plus 10 divided by 8 minus 4i2 equal to 0. So solve for it. Minus 12 plus 100i2 plus 100 divided by 8 minus 4i2 equal to 0. So you make a common denominator for the 8 and solve it. You will get 96 minus 96 plus 100i2 plus 100 minus 32i2 equal to 0. So this 8 multiplied with 0, it will become 0. So I will get here 100 minus 32 here I got I2 as minus 4 divided by 68. So that gives me minus 4 divided by 68 gives me 0.05. So minus 0.05 ampere is the current flowing in I2 loop. Now we have found the value of I2. You can substitute the value of I2 in this equation to find I1. So I am just substituting the value here to find I1. So I will, instead of I2, I will put here minus 0.05. So I will put here 10 times minus 0.05 plus 10 divided by 8 and solve for it. So this will be 10 times 0.05 plus minus 1.18. That gives me I1 current. So when I substituted I1 into this equation, so I find the value of I2 from here and substitute in this equation to find I1. Once you have I1, now you have I2. You can substitute the value of I2 in this equation here to find I3. So I'm just putting here for I3. I3 will be 2 plus 2 times minus 0.05 divided by 4. So solve it. You will get 2 times 0.05 minus 2 divided by 4. It gives me 0.47 ampere as I3. Just check 10 times 0.05 minus 2 plus. Well, this was bigger number. So I got value of I1, I3, and I2. Now you can substitute. You find the values of currents in each loop. If the question says you need to find out current in each circuit, in each resistor, so in 6 ohm resistor, what current is flowing? Only I1 is flowing. So let me clean this up a little bit. So in 6 ohm resistor, only I1 is flowing, right? So this was I1 current. So I can say for 6 ohm, we found that I1 is from I1 is 1.18 amp. So I can say that in 6 ohm resistor, current in 6 ohm resistor is equal to I1, that we found it as 1.18 ampere. What will be current in 4 ohm resistor? So current in 4 ohm resistor so now in 4 ohm resistor, in 4 ohm we are sharing current due to loop 1 and loop 2, right? So let's suppose because of loop 1, the direction of I1 is this way. Because of loop 2, direction of I2 is opposite. Let's suppose I take this as direction. If I take the direction of I1, then I will put here I1 minus I2 as a current in 4 ohm resistor. So what is I1? I1 was 1.18 minus I2. So I2 is minus of minus 0.05. So you add these two here. So that gives me, let me do this addition, 1.18 plus 0.05 gives me 1.23. So this gives me 1.23 ampere is the current in 4 ohm resistor. Then if you have to find current in this 2 ohm resistor here, so this will be I3. So I3 current we already found. So we found I3 as 0.47. So I can say that current in here is 0.47 ampere. And same way, current in this 2 ohm resistor that is in parallel with this 4 ohm resistor. For that, we will see the current will be, if I take the direction of I2, the actual, let's suppose the current in 2 ohm resistor is flowing in this way. I take the direction of I2. So I can say that it will be I2 minus I3 because I3 is in opposite direction. So what was I2? We found I2 as minus 0.05 minus I3. I3 we found as 0.047, 0.47. So that will give me here 0.05 plus 0.47 gives me 0.52. So it gives me negative 0.52 ampere. What this negative represent here? You need to be careful what this negative represent. So negative represent that I was assuming, I took I2 in the beginning here, in the first place, I was assuming that the current is flowing in the I2 direction. I2 is going downward. But this negative represent that my assumption is wrong. It is actually flowing in opposite direction. So it is flowing in this direction. So plus 0.52, the direction will be this way. That means I3 comes first. So I3 minus I2, then it will be plus 0.52, right? So this is how you solve the circuit using mesh analysis. Thank you.